So our topic for today is about from platform-specific models to executable code. So a model of a software or business system that is related to a certain technological platform is known as platform-specific model. So an example, of course, is a specific programming language, operating system, document file, format, or database. So platform-specific models are required for a system's real implementation. So we consider the necessity of to set up an internet store. So users, items, credit cards, and other data will need to be stored in the system. So the designer may choose to use an Oracle database for this purpose. And to make this work, the designer will need to leverage Oracle SQL dialect to describe notions such as the concept of users and a relational model. An example of a platform-specific model is Oracle Particulars Relational Model. Okay? So in the context of the MDA approach, the term platform-specific model is mostly or most commonly employed. And this MDA approach is in the line of the OMGs or model driving engineering objectives. The key concept is that the MTL should be able to convert a platform-independent model into a platform-specific model. And a language complying with the newly specified QVT standard can be used to make this transformation. So, I don't know if you're familiar with Andro MDA, Bayatra, and ATL are example of such languages. So, to give us more details about the topic, let us all welcome our presenter.
Good morning, Dean. This is Ryan F. Gonzaga. My presentation, platform-specific model to execute code. Executable UML is both a software development method and highly abstract software language. It was described for the first time in 2002 in the book Executable UML, Foundation for Modern Driving Architecture. The language combines a subset of the UML, Unified Modeling Language, graphical notation with executable semantics and timing rules. The executable UML method is the successor to the Slur method. Executable UML model can be run, tested, debugged, and measured for performance and can be combined into a less abstract programming language to target a specific implementation. Executable UML supports model driving architecture, MDA tag, specification of platform independent model, and compilation of the platform independent models into graphical notation, executable semantics, and timing rules. The executable UML method, the specific implementation support model driving specification of platform independent. Executable UML is a higher level of abstraction, the third generation programming language. This allows developers to develop at the level of abstraction of the application. The executable UML aims for separation of concerns. This is supposed to increase its use and to lower to cost of software development. This also enables executable UML domains to be cross-platform. That means it is not tied to any specific programming language, platform or technology. Honest developers of abstraction of the application and separation concern increase is software development enables domains to platform uh, specific programming language. Executable UML building blocks. Executable UML building blocks system is composed of multiple subject matters known as domains in executable UML terms. Executable UML is used to model a domain at the level of abstraction to its subject matter independent of implementation concern. The resulting domain model is represented by following elements. The domain chart provides a view of the domain being modeled and the dependencies it as on the other domains. The class diagram defines the classes and class association for the domain. The state chart diagram defines the state event and state transition for a class or instance. The action language defines the action or operation that perform processing on model elements. Abstraction project matter independent. Implementation concerns the domain model represented the following elements resulting UML terms used to model domain at the level. Domain chart. Executable UML requires identification of the domains also known as aspect or concern of the system. Each domain is an autonomous board inhabited by conceptual entities. Each domain can be modeled independent of the other domains in the system, enabling a separation of concerns as an example domains for an automated teller system may include the following. The modeled domains the system enabling a separation concern domains for the automated teller separation concern to include the following. The application domain model of the automated teller's business logic. The security domain model of various issues regarding system security, such as authentication and encryption. The data access domain model of methods for external data usage. The login domain model of the various methods through which the system can or must log information. The user interface domain model of the user interaction with the system. The architecture domain model of the implemented of the executable UML model of the system hardware and software platforms. Class diagram. Conceptual entities such as tangible things, rules, incident, interaction, and specification specific to the domain being modeled are abstract into classes. Classes can have attribute and operation. The relationship between these classes will be integrated with association and generalization, and association may require further abstraction as an association class. Specification specific to the domain being model abstract the class further abstraction as specification model to incident conceptual. State chart diagram. Classes have life cycle which are modeled and executable UML with the state chart diagram. The state chart diagram defines the states, transitions, events, and procedures that define a class behavior. Each states as only one procedure that is execute. You put entry into that state. Procedure is composed of action which are specified in a action language. Defines defines the procedure that defines the behavior. Each state only procedure action which specified in action language. The UML state life cycles model it execute the, the diagram and execute to procedure composed of action language. The class and state models by themselves can be only provide a static view of the domain in order to have a executable model. There must be a way to create class instance, establish association, perform operation of attributes, call state events, etc. And executable UML. This is done using an action language that conforms to the UML action semantics. Uh, the language that conforms to UML, this is done using action language conforms the in order to have model. There must be a way to create instance and themselves to provide static view view association perform operation to UML action semantics. Model testing and execution. Once a domain is modeled, it can be tested independent of the target implementation by executing the model. Each domain can be verified, validated independent of any other domain. This allows errors detected to be associated with the domain and independent of the system concerns. Verification will involve such things as human reviews of the models performed by experts in the relevant domain, and automated checking of the executable UML semantics, checking that the executable UML model complies with the executable UML meta model. Verified, validated, independent domain. This allows error detected involve such things human reviews, relevant domain, checking of the UML UML target implementation, executing model detected to be associated with the domain, system concerns, verification involved, performed by automated executable UML. Model compilation. In order to support execution on the target implementation, the domain model must be translated into a less abstract form. This translation process is called model compilation. Most model compilers target the non-programming language because this allows use of existing compiler technologies. Support execution on the target implementation. The domain model must be translated abstract form. Number of scope of prototypes. The kinds of prototypes just discussed are normally built over the entire period of the development project. This means that we use the entire spectrum of prototype categories depending on the problem involved, especially in large projects. It also means the prototyping is not reduced to the development phase, such as identifying requirements. Development the development project means that entire spectrum of prototype depending on the problem involved, especially in large project development phase, such as identifying requirements. Relation to other document types. Prototypes, apart from relating to all document types described in the chapter, particularly connected to system vision. One reason is that system vision occurred at the decisive interface between the analysis of a current situation and the design of the future system. On the other hand, we have pointed out that system vision only have restricted suitability for discussion between all participating groups. Uh, Analyzing of current situation and design between the chapter are particularly connected system vision, relating, describe, analyzing, uh, suitability are are all participating groups design. Publisher summary. This chapter addresses the integration of constraints and search into programming language from the different points of views. It discusses the various use of constraints, one to model combinatorial optimization problem, and to easily implement search procedure for supporting concurrent computations and to enable open implementation of constraint solvers. Implement search procedure supporting current computation, search into programming language from the different one point, discuss optimization problem and to easily to enable open the publisher implementation of solvers. System at least offer services for finite domains. Most of the known principles and techniques are conceived and document for finite domains. The chapter concludes that finite domains constraint programming system are proved to be useful tools for solving many problems in wide range of application areas. Several useful techniques for the implementation a constraint system are available both for constraint propagation as well as for search. Uh, solve document for infinite domains. Constraint programming system proved to application constraint system are available both constraints techniques service for finite domains for solving many problems in a wide range of application both for constraint. However, because of the change of available hardware platform, the advent of new methods for problem solving and new constraints and propagators and new requirements for system, it is clear that development of constraints programming system will be faced with the many new difficult challenge. Platform constraints programming system will be faced to to hardware difficult propagators and the new system. It's clear that development programming, unlike a typical scientific model, however, an OR model has prescriptive and descriptive purpose in represent human activity with some freedom of choice rather than natural process. The laws of nature become constraints that the activity must observe, and the goal is to maximize some objective subject to the constraints. CP's constraint-oriented approach to problem solving post prescriptive model that's very similar to that OR. Descriptive is represent the laws nature become constraints that activity observed the goal maximize objective subject, constraint CP, constraint oriented. The two problem solving post prescriptive modeling task very similar to the of OR. CP historically has been less concerned with the finding of optimal than feasible solution. However, this superficial difference it is to be expected. Therefore, that OR methods find application in solving CP model. The chapter it concludes that CP can design specialized algorithms for individual constraints or subsets. Constraints there be exploiting subtraction in the problem that OR methods are likely to miss. Design specialized for individual constraints or subject constraint subtractor in the problem solution has been concerned finding optimal the problem likely to CP. Algorithms, on the other hand, can exploit global properties of the problem that CP can only partially capture by propagation drug variable domains.
Okay, thank you very much, sir. So, okay. So, again, as I mentioned earlier, no, I heard a while ago, no. So, the programs are written in interpreted languages that required extra software to run also known as executable code, no? So some interpreted language or languages such as JavaScript, VBScript are left in source code form, while others such as Java and Visual Basic are compiled, no, into intermediate language. So software runtime engines are required to transform interpreted languages into executable execution for a certain central processing unit family that the hardware executes. Then a machine language, runtime engine, linker, compiler, intermediate languages, x86, in Java virtual machine are example of the programming languages. So I think that's it for this topic.